So we ended the last video talking about single replacement. So now we want to move to double replacement. Now, when we have double replacement, it's exactly what it says. You have two things that are coming together, and those two things are going to split up and join with the other two. So, for example, in this one we have silver nitrate joining together with sodium chloride, and what happens is our positive ion here, negative here, positive here, negative here. So the positive and the negative join together, and then we have the positive and the negative that join together there, and that's how we get silver chloride and sodium nitrate. Now, you also still have to be very careful about your charges. I just put plus and minus there, but we do know that silver is +1, chlorine is -1, sodium is +1, and nitrate is -1. So that's why there's no crisscrossing of the charges. However, when we come to zinc sulfide and hydrochloric acid, this is an acid because it starts with a H, when they crisscross, we know that zinc has a charge of +2, chloride has a charge of -1, and therefore that 2 has to be crisscrossed down there for chloride. The same goes for hydrosulfuric acid, where you have hydrogen with a +1 charge, sodium with a -2 charge, so that is crisscrossed down. I will let you know that I will be expecting for you to be able to do this if I give you the word form of it. So if I by chance give you sodium sulfate reacts with barium chloride, and let's say that that is all that I gave you, I would be expecting for you to be able to tell me, well, first of all, what type of reaction it is. You would see that you have sodium and sulfate, and you have barium and chloride. So you have a double replacement reaction going on. And then you would then need to know that sodium reacts with chloride, sulfate and barium come together, and then you would need to be able to write it out for me in the correct chemical formula, crisscrossing those charges correctly. And lastly, going back and balancing the equation, which is why they have this 2 right here in front of NaCl, because they needed to balance the sodium and the chloride. Last reaction that we want to talk about is called the combustion reaction. Combustion basically just means that stuff is blowing up. So when you think of combustion, I want you to think of a fire. And one thing that a fire needs in order to continue on is oxygen. So you have something with C and H coming together with oxygen. And it always yields this over here. So if you have a CH reactant coming together with oxygen, you don't have to see what replaces what. You don't have to see, does this come first? Is this positive? Is this negative? Who's going to join with who? It always produces these products. So that makes this one the easiest of all when it comes to knowing what the products are. Now, I will tell you that sometimes these are the most difficult to balance. And I say that simply because, for example, you have a CH reactant, it has C and H only, and it's reacting with oxygen. And of course, it yields this. And of course, we know we have energy over here. You do not have to write energy if you don't want to. I'm not going to be picky about that, but I do definitely want to see the carbon dioxide and the water being formed. So if I give you just this first part here, and say that it reacts with oxygen, or even if I say C3H8 combusts, you should be able to write this entire equation for me and be able to balance it.